Okay, we have a little bit to finish over 3/7. Let's get your notes out. Okay, so the reason why this 3.7, this type of question is in 3.7, is because when you want to find the domain of a radical, well, you know that radicals, what's underneath needs to be positive. So I take what's underneath and I set up this inequality. So actually, what I'm doing is the same thing that I have been doing. So the only extra stuff here was you're finding domain, so you have to set up your inequality. Okay. Well, just like before, let's find the zeros. So you want to do 25 minus x squared equals 0. And I can leave it just like this. I know that's not standard form, but this gives me difference of squares. So we're finding domain. We're not solving this radical equation. We're finding the domain. So domain of a radical function has to be positive. So that's why I set up the inequality. So I'm solving the inequality. Okay, so difference of squares. So this will be 5 plus x, 5 minus x. All right, now when I want to find the zeros, so you could think about setting each part equal to 0, but it shouldn't be too hard, right? So what would x be to give me 0 here? Negative 5, and what about here? Positive 5. So you're still getting 5 and negative 5 as your answers. Okay, so once you find the zeros, graph them on a number line. Radicals can equal 0, so this is why I have that equal to part. So I know that the circles will be closed. Okay. So now I need to look at my parabola. So what is the leading coefficient? -1. So this is not in standard form. My leading coefficient is right here. It's -1. So what does that mean about my parabola? It opens down. And it's greater than, so you want the part that's above. So that's this part right here. So then on your number line, that corresponds to right here, and the closed circles mean that you have brackets. So -5 to +5. Questions about that? Okay. If you were to graph this function, just this radical function here, it actually is just a semicircle. And we've done this before, but in chapter 2. So the graph looks like this, which is why it gives me a domain from -5 to +5. Okay, we could still do the quadratic to help us find that domain. If you do a quadratic inequality, it gives you the same domain as what it would originally as a semicircle. you want to find domain. So that means it's a square root. So what's underneath has to be positive. So you set up this inequality and then solve the inequality. So solve the inequality like we did yesterday. Find the zeros. Can you factor this? Yes, you can factor out an x. You could, if you don't think you could factor that, then you can use quadratic formula. That would work. But what would a be? -1, and b would be 6, and c would be 0. So you can do that if you don't see that this factors. Okay, so my zeros would be for this x out here, and for this 6. Okay, good. So graph those on a number line. And it can be equal to 0, so I know I have closed circles. My leading coefficient is -1. It's the a value, so -1. So this parabola opens down. Okay? And we want greater than, so this again will be between these two numbers. This part here, which corresponds to this. Questions about that so far? Okay. Let's look at one more domain. So set up your inequality and then find your zeros. Okay, so start there. So this factors. So what multiplies to give me +9 and adds to give me -6? Good. Okay, so my zeros are 3. So 3 has a multiplicity of 2. Okay, let's graph this on the number line. Again, it's greater than or equal to, so close circle. Multiplicity of 3 means on the graph it would, yep, bounce. What's the leading coefficient? 1. So does this open up or down? And we want greater than, so above. Okay, well this part's above, and this part is above. Okay, so on the number line that corresponds to this, and this. So I have a closed circle that's 3, so does that mean I include 3? Yeah, so the whole number line is shaded. So that means it's all real. So -infinity to +infinity. questions about that? Okay, so that is it.